Hi, for those joining. Thanks so much. We're going to give it a couple minutes just to see how many people dial in, and we'll kick off in just a moment. Okay, thanks so much for joining us. Our webinar today is Arrested Development, How Third-Party Dependencies Can Kill Your Product. I'm Donnie Hasseltine. I'm the Chief Executive Officer of Packagecloud, a software repository management provider. And then I'm also joined by one of my colleagues and good friends, Jason Gilmore, who's the CEO of Treehouse. So I'll pass over to Jason to do a quick intro for himself.
Sure thing. Thanks, Donnie. Before I begin, excuse me if I cough occasionally. I'm just getting over a bit of a cold, but I'll do my best to tone it down. So again, my name is Jason Gilmore, and I am serve as the CEO for a pretty cool company called Treehouse. Treehouse is an online educational platform that simply put teaches people how to code. So if you have an interest in learning more about JavaScript or Python or databases, or maybe you want to learn about UX design, Treehouse offers a pretty solid program to become proficient and then potentially land a job in the tech industry or nail that promotion within your existing company. So feel free to check it out at teamtreehouse.com if you have a chance. Prior to joining Treehouse, I served for several years as the CTO of a company named Dream Factory. Dream Factory is an API generation, builds an API generation platform that's used by companies around the world. Prior to that, I worked with a number of development teams in the telecom industry, architecture and design, education, publishing, the environmental industry, and we basically built custom products for a variety of companies over that period. And I guess finally, I'm the author of quite a few books on web development, including most recently 2 books on the Laravel framework. I'll hand it back to you, Donnie.
Yeah, thanks. And I'll give you a little more about my background, whereas Jason has been really deep into tech his whole career. I started out in the military and spent 22 years at the Marine Corps, traveling around the world and deploying with them. And then later on, as I was getting out, made a shift into cybersecurity. I did a master's program at Brown University, and then I've gotten fairly deep into the cybersecurity world before coming to Packagecloud. I also work with InfraGard, which is a public-private partnership to support critical infrastructure. We work with the FBI to help protect our critical infrastructure around the United States, taking private sector leaders and marrying them with government teammates. And now running Packagecloud and looking to apply that expertise at how we can help protect individual companies that are using us to deploy their software. So I thought we'd kick it off with a couple of just quick questions to start the conversation. First, just a little bit about, do you know what kind of tools you're using right now, and then a little bit about who's tracking that software dependencies at your company. So you should see these polls pop up. We'll ask, you have someone assigned to tools you use, and then we'll throw 2 more questions out there as we kick it off there. And please just join on because it'll help us bring the conversation along. Based off our bios, you know, Jason's been doing this for a long time. He's written a lot of books on it. So we want to first start and step back and kind of just talk a little bit about how modern software development actually works. Software is so pervasive. Everyone uses it in their everyday lives. But when you peel it back, it's really kind of a little crazy to understand like how it's built and how it's maintained and how it provides those experiences to you. So I think the first way to start is maybe jump back and talk a little bit about what did it look like back from the beginning, because when Jason was at that beginning, starting that coding, I was traveling around with the Marine Corps with my face painted. So before I jumped into tech. So I'll hand over to Jason on this next slide to talk a little bit about how we got here.
Sure, thanks, Donnie. So when the Packagecloud team invited me to join this webinar a few weeks ago, I kind of used it as an opportunity to, I guess, reflect on what has transpired over the course of really the last, I guess, 25 years, give or take, really starting with the launch of the modern web as we know it. I've been developing websites effectively since the web came about and became, I guess, much more of a public phenomenon. And for those of you who were not building websites back in the mid to late 90s, I think it's difficult to appreciate the position in which we find ourselves today. And I'll talk more about what that means in a moment. But back then, I mean, this idea, which we take for granted today, this idea of being able to build a website, build a simple web application, deploy it to some server, and have that software be effectively immediately available, not to just your team, not to just your company, but the entire world, was a pretty amazing development. And naturally, a lot of buzz, a lot of excitement going on at that time because of it. But when you kind of really focus in on what developers were doing at that time, I think it's hard to understand just how much custom code was being written. There really were no widespread libraries being used, code libraries. There were no frameworks, certainly none as we know it today. These were all, very new concepts, right? So what we would do is we would write the authentication solution if you were managing users and sessions, right? We would write the interface between the website and the database, typically using some internal library that was part of the language, PHP for development, or for example, had and still does a native MySQL library. So you would use that to interface directly with the database. You weren't using an ORM, right? An object relational map library, I guess is what I'm getting at. There was no configuration management library. So you were writing the custom code to manage that. You were writing custom code to manage your web templates, if there were any. I mean, might have had a bunch of static or somewhat static pages that you were maintaining for an application. So my point here is this was all largely custom code that was being written over and over again, right? You might have some internal libraries that you were using if you were trying to be a little more efficient, but you weren't really relying on a larger ecosystem other than, maybe to copy code from a snippet website, right? And incorporate that into your application. So I would say there were really three major developments that took us from that position to where we find ourselves today. And the first happened around 1998. And that involved a mix-up between Netscape, so the Netscape browser, and Microsoft, who had released the Internet Explorer browser. So believe it or not, the Netscape browser was actually a paid product. I think it was, don't quote me on this, but I think it was like $49.95. That might even have been annually back then. But anyway, you paid for this browser. And Netscape was, I think it was the IPO of the year in 1995, was definitely a tech darling. And here comes Microsoft, and Microsoft releases Internet Explorer, but they make it available for free. And of course, this has a dramatic impact on the trajectory of Netscape because people are, of course, not going to gravitate towards not only a Microsoft product, but one, of course, that was free. And what that resulted in was Netscape making, which at the time was this groundbreaking decision to open source their browser, not only make it free, but open source it. And that code was the genesis for the Mozilla Foundation, right? And Mozilla, of course, manages, among other products, the Firefox browser today. So I identify this point in time as one of the three major events leading up to how we build software today, because I think that was a real wake-up call for corporations in which they finally started thinking or treating this concept of open source software differently, right? Like it became a topic of much more conversation within corporate environments. And what does that mean? It means they started becoming more comfortable with this idea of using open source software. And because the businesses became more comfortable with it, so did the developers. A little maybe interesting anecdote about that, that decision. That decision apparently was largely influenced by the writings of an open source advocate named Eric S. Raymond, and he wrote a paper called The Cathedral and the Bazaar, which became a quite famous paper about the advantages of open source software. And that paper that eventually turned into a book, actually published by O'Reilly, but that essay is available online. And if you haven't heard of it before, I highly recommend it. So that was kind of major milestone one, right? Businesses became more comfortable with this idea of using open source software. The second development, as we proceeded into the aughts, the second development came about due to developers, frankly, kind of throwing up their arms and saying, oh, aren't we supposed to be about abstractions? Like, why are we writing this code, this custom code over and over again? And because of that, groups of developers within the different communities started getting together and started building package managers, one of which was PyPy for Python. And that came out in, I think, 02 or maybe 03. And that package manager, the PyPy package manager, offered a vehicle for finding and then, of course, downloading and installing third-party Python packages. So now we're starting this transition away from writing all of this custom code to one in which we're starting to rely upon this third-party software. Python came out, Ruby Gems, PyPy came out, Ruby Gems came out very closely thereafter, which is the package manager for Ruby. And then in, again, I don't remember the exact date, 04 or 05, there was a really groundbreaking change, and that was the release of the Ruby on Rails web framework. And the Ruby on Rails web framework at the time was just this, for so many web developers, this just mind-blowing development, because it packaged together configuration management, validators, template managers, an ORM called Active Record for easily talking to your database. It put all of this together within a single downloadable package and effectively removed all of the decisions that developers otherwise had to make regarding the internal plumbing of these applications. And what did that do? That gave developers far more time to work on the user-facing features, right? I mean, this was, I cannot overstate how significant a productivity boost that this was for developers. And many of the pieces or the components that comprised Ruby on Rails were actually themselves packages that you could download and use separately, of course, but they all came together in Rails. So developers, because of this, started becoming really familiar, if not just outright dependent upon using third-party software as the basis for these new applications. Once that happened, you saw frameworks rolling out for all of the other major web languages. You saw Symfony come out soon thereafter, which is a PHP framework. Django came out in 05, which is a framework for Python. Laravel came out not till I think 2011, but very much followed in the footsteps of its predecessors in terms of offering those types of capabilities. So now we've moved from custom development for everything to very much an ecosystem where developers are relying on this third-party software, whether it's through libraries or through frameworks. The third development that I really poured gasoline on this fire was GitHub. So GitHub was launched in 2008 and just took off like a rocket from there. I think by the end of year one, there were something like 46,000 repositories hosted, the bulk of which came in like that last month of reporting, if I remember reading this correctly. Well, GitHub, of course, these days is the de facto place for managing practically all of these packages that you find on within the package managers, and really is the go-to, right? I mean, any dev on this call can relate to, okay, I need a package. I'm going to Google for the thing I'm trying to do. I'm going to see a GitHub result in the search engine listing. I'm going to click on that, read the README, and go ahead and install that using the appropriate package manager, right? So we've, over the course of these 25 years, we've evolved to the point where programming, and I try and explain this to beginners sometimes, and I think it's an epiphany for them, where programming has become almost Lego block-like, where we're snapping Lego blocks together rather than writing all of this custom code. And that is a pretty amazing position to be in, because we can build far more powerful applications far faster and far more securely because of it. So what's the problem here?
Yeah, thanks, Jason. I'll take up from there, because when you think about it, we all like to build new things. We all like to do novel things, right? That's kind of part of what makes us human. So when Jason was talking about that, if you're trying to build out a simple line of code that just, for example, reorients things on a website, sets it on a left justifier, things like that, that might take some time, because you got to think through it. You got to think through the logical steps. You've got to write it down. You've got to test it. Then you've got to apply it. And that might take half hour, 2 hours, where you could be focusing on those individual elements that you really want to focus on. So like Jason said, it's much easier. Can I just go find the Lego block that does that and just snap it into my software? And then what you end up with is things like this. So on the left-hand side is an 11-line piece of code. It's called ft-pad. It was in the NPM registry. And this was by a developer who just basically, when he would solve a problem like this, he would just put it up. And then someone else could say, you know what, I need something that'll do this. Where can I look? Oh, there it is. Pull that Lego piece in and snap it in. So that really set up, like Jason said, the real acceleration of pouring gas on the fire to get software development blowing out. But the challenge then becomes is like, where is that actual piece of code? Who wrote it? And is it still there when I need it? And what ended up happening was a trademark dispute. This developer had another thing he was working on that happened to share a name with a Canadian company. They reached out to him. They wanted him to change the name and take the name down. Did not go very well. So he said, you know what? I'm going to pull all my code down. So he made the decision just to take and delete all the code he'd had in the NPM registry up there. And what that immediately did is it pretty much broke the internet. This happened about 2016, including, ironically, the company that was trying to sue him to take down for a trademark request, because everybody who went in then suddenly got this error, which is simply as your computer rendered that web page, as it was trying to organize the pieces on the screen, it was looking for the code to tell it where to put certain things on the left side. And that software told it, hey, when you get to this stage, look at the NPM registry, read the 11 lines of code that are there, do that, and then go to the next step. When everything hit that step, everyone got that 404 error that you see on the right-hand side of the page, which caused a catastrophic cascading effect across the internet, because everybody happened to be relying on that one section of 11 lines of code. So to graphically kind of depict this, and I'll throw it back to Jason briefly, really all those fancy websites you have kind of look like this, right, Jason?
They very much do. And in so much that for anybody who's used a package manager to install software, to install dependencies, I always marvel at once you run that install command, at the sometimes screen after screen of code that rolls by with, letting you know what's being located, what's being installed, and so forth. And I marvel at that, because you really have to, every once in a while, take a step back and realize that every single line of code that is not only found in that package manager, but in all of those dependencies, naturally it's been written by a human, right? These are largely individuals from around the globe who are contributing open source software in their free time, in the evenings, in the weekends, sometimes at work, depending on your job. And people get stressed out, right? People decide they don't want to do this anymore. People get bored. And it's important to have that context, because as this XKCD comic illustrates, and as the left pad example Donnie just discussed illustrates, there's a lot of mission critical software out there that is reliant on someone's pet project. And sometimes people get mad and they take that football away, right? And when they take that ball away from the game, things can fall apart quite quickly.
And I think that brings up a couple of interesting points, because, like, let's say someone gets tired and hands off the maintenance to someone else. There's no background check. No one's checking to see who this person is now taking over those. And when you own these different little pieces of code, it's very easy for you to make a change to it that has rapid and cascading downstream effects towards a lot of software. So Jason talked early on the history of how we started off with individual developers who are kind of building everything. And we've shifted now this Lego block system. Now we add in like all the different things that make developers' lives easier and get that product to market in a faster and more efficient path. And we've asked a couple poll questions out there, and I'll just hit it. Like, we're going to talk about dependencies in a few minutes, but it looks like about a third of the audience is either the individual who they're relying on to track some of these issues. 33% or so is about a team, and there's about another third that they don't have anyone assigned to this. Within our group who's listening today, about the same thing. About 50% are business focused and kind of looking at the big picture here. And about 25% are a developer and a team, and about 25% are individual contributors. So when you think about that, and you think about all the different tools that are out there that assemble this, it creates really a supply chain. And we've on the news now, you're hearing a lot of things about physical supply chains, like some of the crunches we had last summer. But software has a supply chain too, because it has now so many people somehow tied into it, some paid by the company that's delivering that software, and some of those individual maintainers kind of hanging out in the background doing great work and kind of keeping everything afloat, really thanklessly in the background. So if we explode this out now to what it kind of looks like now, I'd say this is kind of what the software supply chain looks like. And I'll hand over to Jason to kind of walk through it. And then I'm going to jump back in and from a cybersecurity perspective, talk about some different ways you can kind of attack this and cause problems to this ecosystem. Jason?
So I really like the use of this term software supply chain, because when you think about what a modern software development process looks like within a mature organization, you can almost think of that internal process as this diagram partially illustrates as your manufacturing facility. Like, imagine, like, think about a factory, right? Maybe an auto manufacturer, and you have this raw material come in, and then over the course of the next few hours, that raw material is assembled together and an automobile pops out the other side. That same idea can be applied to the software development process. We're bringing in this raw material, these third-party packages which form the software supply chain, and just as we have matured over the last 25 years in terms of coming around to the fact that building software using third-party software is great, so have we matured in terms of having a much more structured process, right? And that, again, is our manufacturing facility. These third-party dependencies come in, and what are we going to do? We're going to install them into our source, our application source. And then as we become happy, right, with the progress, what are we going to do? We're going to start building and packaging that software, right? Our software, to be clear, our application. And then finally, we're going to deploy that code. If we're building web applications, we're obviously deploying it to our cloud environment, or alternatively, we might be building coding editors or database clients or what have you, where we're going to make that code available for download, maybe via package managers like Ruby Gems or PyPy or what have you, right? It's important to point out that each of these steps, particularly in a larger organization, could be managed by a different team. And it's also important to point out that, as Donnie will illustrate here in a moment, each of these steps present risks. There are software supply chain attacks that can be mounted within each of these parts of your manufacturing facility.
Yeah, so if we throw it out, I'm going to throw out a few of the different things and maybe just talk through some examples you may be familiar with. So first of all, you could have bad code submitted directly into the original source. This happened not too long ago with the University of Minnesota, who submitted a malicious addition directly into the Linux kernel, so that the source code that operates all Linux machines and all Linux programs out there. There's a lot of discussion. You can look it up about the motivations and why they did it and what happened. But then you can go into like your actual source control. And in this case, I'll have Jason talk a little more in detail about a really interesting PHP hack based off his background in the PHP language that occurred here. You could talk about that code can get modified after it leaves the source and is in that build process. If you compromise that overall build platform, that CI/CD, the SolarWinds attack, which I think many people are familiar with from the news, that's a great example of being able to compromise the build platform. And once you own that, you can really infect the entire software supply chain from there. You can use bad dependencies. And we'll talk about a couple examples of that where, like we said, someone is pulling that one package, that one piece of code, and they use the wrong one. They have the wrong name, or a name that looks very, very similar. And that immediately then pulls that malicious code into their system. There could be a case, CodeCov, which is a pretty big company that was hacked not too long ago. And in that case, it was a case where someone uploaded and basically was able to bypass the CI/CD process and use some leak credentials to get a malicious artifact into that process, so the packages that went out were compromised. There's a lot of research on ways you can compromise package repositories. And then once it's all the way out there, there's also ways you could just happen to use the wrong package, right? Like Jason said earlier, you picked the wrong name, you got the wrong dependency, you got the wrong package, and that immediately infects what you're doing. So we can't cover all these in the short time we have, but we're going to jump into a few and go a little deeper just to give you a sense of like where the risks are and where you should be looking as you move forward. So Jason, maybe you can talk about the PHP hack here.
Sure. And it really is important to, I guess, illustrate or point out that each of those components where Donnie highlighted to compromise, the potential for compromise, this isn't academic at this point. I mean, this has happened in numerous different situations over the past few years and seems to be getting worse, frankly. So the first example, it's a really interesting example, involves an attack in which the attacker compromised a local Git repository. So the PHP team was managing their repository on a local Git server. So it was a server that they were managing locally. At some point, a third party got into that server and managed, I'm not sure exactly the details are a little sparse, but they must have created an account having the same name as two of the leading PHP contributors. Nikita Popov, I think, was one, and then Rasmus Leerdorf, who was the creator of PHP. So this individual was able to basically masquerade as these individuals and push two commits to the PHP source repository, which were really malicious. And in so much that had this code, and it didn't, to be clear, had this code been merged into the code base, the third party would have been able to make a request to that server with an HTTP header that had a name starting with, as the second screenshot indicates, 0dm. And the value of that header could conceivably contain PHP code that would have executed on that server. So, I mean, I don't think it gets worse than this, really. Like this would have been an opportunity for this individual to attack any PHP server or any server that had that particular version of PHP installed. And I mean, basically create no small amount of havoc as a result. So great example of a situation where this individual realized that there was an attack vector to be had through the server in which the repository is being managed, masqueraded as clearly very well-known individuals and then tried to sneak 2 commits into that source. This was caught, to be clear, and they actually wound up moving to GitHub, their repository to GitHub as a result of this, just concluding that there was too much risk managing that server locally. But I really like this, one, because it's particularly ugly, particularly devious, if you will, and then the ramifications, had it gone through, had those commits been merged, would have been quite serious for a certain period of time.
Yeah, and Jason hit a couple things in there, and one of the interesting things that this is a case where someone is now impersonating the actual contributors and looking like the right people that people trust. Trust is a key thing. The internet was built on trust, but now people are exploiting that, and you have to think about creative ways to identify where those attacks might come from and defend against it. So there's 2 here that are pretty interesting. These kind of fall under what's called typo squatting, where you either create a typo or you change a name and you hope someone's going to go for the wrong one, right? Interesting enough, the dependency confusion one that I just popped out, Alex Pearson, you can look this up on Medium. It's a really fascinating attack, and it's really a great article that even if you're non-technical, you can read through and get. But essentially, Alex was a white hat hacker. He's basically just trying to look for potential issues. And he was kind of brainstorming one day, understand that once those software was in the wild, right, he would call back to run lines of code in these different packages. And he looked at some things like at PayPal, I think was the first one he looked at, and thought, okay, there's a couple things to think about here. What happens? You're trusting basically these individual packages to just run software on your machine. So can that blind trust be exploited? And what he initially looked at is a lot of these individual pieces of software, in this case, PayPal's, was looking at a private repository. The good thing about a private repository, it's secured. There's ways to use keys and otherwise to basically secure that pathway. So you're only pulling from a known repository that is in a secured location that people can't access. What he just said, he said, what happens if I take one of these packages that are private, and what if I just release a public one that's of the same name? What's going to happen? And what he found is the software inevitably defaulted to take the public one. So as he started looking through, he looked through Netflix, he looked through Apple, looked through a number of other companies, and found a lot of these cases where the packages they relied on were pointed at a private repository, but that name was open in the public. So he just registered that name, set it up, and then showed that when you run that software, it would pull whatever he put into it into that public piece. Thankfully, he was on the good guy's side. He reached out to each of these different companies, showed it, and they immediately started patching these pieces and setting parameters to ensure it looked specifically at the private repository first and prioritize that. So that's one way where you can just use the exact same name. But then there's some other things where you can kind of just change the name slightly, and people will often, being human, make a mistake and pull the wrong one. And I think the rowserify one is a really fascinating one that I think, if I remember correctly, Jason, it took down Etsy for a period of time, didn't it?
So yeah, the rowserify attack was I think a prime example of dependency confusion, in that rowserify, being an extraordinarily popular NPM package, I think it's installed, like 2 million times a week on average. So very, very popular package. Some enterprising attacker decided to create a package called web-browserify. And this web-browserify package was particularly malicious in that it did 3 things. One, for reasons I really can't quite understand, other than just wanting to damage computers, it deleted the Etsy, all of the contents of the server's Etsy directory, or the laptop. Obviously, if you're running this locally on a Mac or Linux machine, it would have done the same. It would have severely damaged your laptop operating system. And it did that by relying on another package, an NPM package called sudo something or other. And what that sudo package does is it actually prompts the user to enter their admin password. So once the dependency had that, it then had the power to go ahead and delete the Etsy directory. So that was one. Two, it installed itself onto the bootloader. So every time that machine rebooted, it was basically running again. And then 3, it gathered up a whole bunch of attributes about that particular machine, IP address, CPU, RAM, like all of the specifications for that machine, and it forwarded that data on to a some remote server residing elsewhere. So a particularly ugly example of a dependency confusion attack, which not only stole some data from that machine, namely the server specifications, but it also damaged the machine as a result.
Yeah, and for those who are not technical out there, your etc directory is where all the configuration files really sit, particularly in Linux. So when you take that down, you lose virtually everything across that entire program or operating system, and causes, again, a lot of really terrible cascading effects that make you fairly unusable. The other one that I think you were going to talk about on another typo squatting is the ossenv example. So you want to talk through this one too, Jason?
Sure. So the second example also involved an attack associated with a very popular package called cross-env, cross-env. And what cross-env does is it helps manage your environment variables basically according to the environment you're in. So development, staging, production, right? It helps manage effectively which set of environment variables should be used according to the environment you're in. And so this is an example of both dependency confusion and more notably typo squatting, where all the attacker did was took the dash out of cross-env, releasing a package called cross-env. And this attack is interesting in that it actually worked like the cross-env package. It did what it said the original package was going to do. But in addition to that, it took those environment variables and it uploaded them to a remote server. And imagine the potential outcomes of this. It could have grabbed your AWS keys. It could have grabbed your Google Cloud keys. It could have grabbed API keys for third-party systems that you're using. It could have grabbed your database credentials, your username, your password, your host name for that database. And if that database wasn't configured to specifically allow connections only from that application server, now that third party could have logged in using those credentials and deleted your database data or stole it or what have you. So this is a great example for several reasons, one of which is typo squatting, but second, it actually behaved like one would have expected, and with the additional bonus, if you will, of stealing all of your environment variables.
Yeah, and I think that's a really important point for people to recognize is if you do get compromised in one of these points, that doesn't mean things will actually go wrong right off the bat. In fact, if you think about the SolarWinds hack, that existed for a long period of time where they got in, they compromised it, and they made sure the tools all worked seamlessly so no one noticed, but then subtly uploaded ways to capture data, pull data off, and go things like that. They hopefully intended for nothing to break along the process and to be so seamless that no one noticed it, but then all the while stealing information that could be used for additional malicious attacks. And when those attacks kick off, you don't know exactly how do they get the credentials, how do they get access to this. You could potentially maintain that access point in that software supply chain for repeated differing attacks over time. So just because everything is working the way it looks like it's intended doesn't mean there's not a problem. And I think that the key thing to understand about this is you really have to know what's actually in the software. And that doesn't mean just at the time of release, but even down the road. And another funny XKCD approach to look at, I'll throw that up there on the screen for a minute, is there can be a line of code in there that doesn't look like it does anything, but if you don't know what it does, it can ambush you at a later date. So we talked a little of this in the last 10 minutes or so. What I'd like to do is talk a little bit about some ways that you can make sure you're doing the right thing to protect against this. There's no direct one-size-fits-all solution to it, But there's a lot of different things that you can consider or have your teams look at and ask the right questions of to make sure you're being responsible to how software is managed out there. And then the other thing is, we didn't cover this at the beginning, but if you have a question, you should be able to pull up the Q&A button on Zoom. Feel free to throw any questions in, and if you pop them up now, we'll get to them at the end. And then once we get open a Q&A, feel free to throw them out there as well. So let's just jump on to some things we can do to protect against some of these attacks that Jason and I have talked about. I'll let Jason kick off and I'll finish.
Sure, thanks, Donnie. So naturally, leave it to developers to devise automated solutions to try to fix these sorts of issues. And there are several great tools out there that can go a very long way towards helping you, at a minimum, be aware of potential issues, if not outright help you fix them. Probably the most, I think, widespread and commonly known tool would be Dependabot. So what Dependabot does, it's a GitHub utility that you can enable on your GitHub account. And what it will do is it will review your package manifest, right? So your dependency manifest, package.json, composer.json, and it will look for security issues. And if it finds security issues, it has this really cool feature where it will actually submit a pull request, automated pull request with the fix. At a minimum, it will alert you to the potential issues, right? So Dependabot's available on GitHub. We use it at Treehouse. I mean, most repositories that I've encountered over the past few years do the same. Second option, and there I'm just using the OWASP example just as a for instance. So OWASP, if you're not familiar with the organization, is the Open Web Application Security Project. They release a lot of great information about security issues, security advice, and so forth. They have a number of annual top 10 lists that come out, like top 10 most prominent web application security issues, top 10 most prominent REST API issues, and so forth. Well, there's a tool called the OWASP Dependency Check. It's a utility that you can install, which relies upon a large vulnerability database to review your dependencies and again notify you of potential issues. There's also the CVE databases. There's quite a few of these out there. You can configure these databases to send Slack notifications anytime a significant security issue pops up that is of interest to you. You can, well, before we get into the bullet points on the right, there's also a fourth item that we just wanted to pass along. Donnie has always offered a really great explanation of the of Google's Salsa project. So I'll go ahead and pass it over to Donnie to introduce that.
Yeah, so the Salsa project is something that came about last year, where we started seeing increased supply chain attacks. There's a lot more focus on it. So a lot of individuals and companies started coming together like, what can we do about this? And Google took the lead here, working with the Open Source Software Foundation to create Salsa. slsa.dev is the website. And it stands for Supply Chain Levels for Software Artifacts. It's still being built out right now. It's still very much in the initial phases. And if you're of interest, welcome you to kind of reach out to the team that's leading it and jump on the calls and kind of contribute as well. But essentially, we've broken this out into like 4 different levels of different things to establish software provenance, but knowing where all those software elements come from. Some of this is just some basic security pieces and basic good hygiene to make sure you're doing the right thing. And it gets more complex as you move along. Like, can you prove and ensure that you have 2-person security so that every time a pull request or a piece of code is added, someone else checks it and double checks it. So you have 2 people looking at it. So no one person can actively control the code base. So level 1 is kind of more easy to adopt. It kind of gives you just some basic visibility and starts helping you generate provenance of your software. Level 2 starts closing some of those doors we talked about on the supply chain to prevent software tampering and start setting some basic integrity guarantees. When you get to level 3, you're dealing with your infrastructure and making sure infrastructure is secured against attacks, and that broader trust is blended into more complex systems. And then when you get to 4, you basically adhere to really best practices across the industry for dependency management. This is a great framework. You can look on GitHub and pull it down. You can look at the website, slsa.dev. And because if you're handling software, these are the things you should be doing already. So it's a great checklist. But if you do this, I think they're going to get to the point where you can put a badge on the site and demonstrate it. And what's great is if I'm a user who comes to download software, it helps them understand, okay, there are steps being taken on the backside to better secure this software. I can trust this software at a higher level because the provenance has been established. I can audit that provenance. I can see it. These are the sort of things we're trying to get to, because ultimately we want someone to understand, like if you remember that XKCD cartoon at the beginning. In fact, I'll pull it up real quick as an example. But can you understand what's in here? And another piece of that is software bill of materials. That's a piece of it. Do you know all the little components that are in there? And can you establish where each of those individual blocks came from, right? If you know where that came from, if you know who built it, if you know who wrote it, that gives you a lot more advantage into being able to defend against potential problems out there. So I think that's a pretty good coverage. We're coming up at about 45, 50 minutes. I'm going to tease out a few things and answer a couple of questions that have come out. One of the things we've talked about is what can we do about it, right? If we think about Packagecloud specifically on the point of one end at that deployment integrity, even when we think about what Jason does at Treehouse about educating developers at that source and build level, what are the things we can potentially do out there to make things better? And so a couple of things we're playing around with is, are there ways to help developers and help companies that are releasing products by managing how those dependencies are called, right? There are ways, like Jason said, you can pin them and wrap them into the software, which works. If you've audited at that point, you can lock it to a certain version. But then once it's out there, if something happens to the version that you've locked to, you've got to be able to see it. And one of the things we've looked at is, can we, instead of redirecting all of those dependencies out in the open where they exist in the internet, can we vet them and bring them through Packagecloud? So you're looking back through Packagecloud servers, and we're only allowing you to basically use dependencies that we've also checked and help give you an additional level of assurance that if you're not looking at it on a day-to-day basis, someone is looking at it and giving you assurance that dependency is secured. Or we can go back and flag it to that developer and say, heads up, this has happened. It's something you should take a look at. The other piece we're playing around with right now is code ancestry, which is, you probably know pretty closely what your individual code came from and how it built out. But the problem is, most software, I think, breaks down. I think, Jason, you may remember better than me, but I think it comes out to roughly about 20% custom unique code and about 80% dependencies or other packages pulled across the internet. So if you're using that much, you may know where that 20% comes from, but do you know everything that went into that other 80%? So part of understanding that is, can we look back and look at your package and say, all right, we can look not just at your work, we can look at all the open source dependencies that are out there and identify who the individual contributors were. Looking at GitHub, for example, can we now assign some type of reputation scores to it? And then flag you when we see something doesn't look right, right? If there's an unverified commit out there, can we go back to that contributor and verify who they are? And then say, hey, can you make this a verified commit? So we've signed it, we know you actually did it, right? The other aspect of this is, this would flag in a case like, say, someone joins an open source development team and is contributing code, and then they post a pull request that gets submitted and added to that code. But then we look at it and say, it's really odd. This person we don't recognize. They haven't committed to this code base before. They've only done 1 or 2 total commits on GitHub entirely. That starts to change the reputation score, where one person does 1 or 2 unverified commits, nothing else, we can't see them anywhere else in the greater software world. That might be a flag. That's something to look at in a little more detail. Whereas you might have individual developers that everybody knows. I know that is, I recognize the username. It's not an impersonation. I can trust that. Or someone who's done a significant amount of verified commits that we've known over time, that's contributed multiple packages. Now we're starting to get into a realm where we have a level of trust. So can those reputation scores better inform you, so you don't just, hey, this looks like it's got 5 stars on GitHub, I'm going to run it. Before you get it out there, can we say, you might want to take a look at this, and more specifically, you want to look at this specific line of code. So with that, we'll pause and jump in a few questions The first one was served up. Neil, I'll answer yours. I think it's a great question. He's talking about the tension between creeping featureism, i.e., supporting more and more package management systems. So as you're building software, can you support it in more languages and frameworks? And then you end up having multiple different verification systems that are different in different places. So I think, and Neil, you can chat back if I'm not answering the question correctly, but he asked about how we navigate that hazard. And I think one of the great things about using a package manager like Packagecloud is no matter what language and frameworks you're using, no matter what types of package you're using, you can put them all in one place. And being able to see everything in one place, have your user be able to select what they need and understand it's all one place, that also saves your time as a developer from having to go to multiple different locations to check and maintain those packages. So as you get told, hey, could you release this in Debian? Could you release this in Ruby? And you go ahead and do that, instead of putting them in those different package managers and repositories we talked about early on, put them in a central repository where you have control that you can view and answer questions of and validate. It makes it just a lot simpler than checking out. You don't have to learn different processes. You don't have to look in different places. Everyone knows where to look at things and knows how to validate it there. Jason, I don't know if you want to add anything more to that question from Neil.
This is actually a really interesting question. And just to add to it, now what you're seeing on the screen right now is, to my understanding, and I don't want to put words in Packagecloud's mouth, but what you're seeing on the screen is an early version of a really cool new feature Packagecloud is working on. But what I really like about it is it's effectively abstracting away this process of verification, and we're looking in this case at human and process heuristics. Well, regardless of the number of package management systems being used, I mean, this type of control can be globally applied, right? It's applicable regardless of the situation, right? If we see an relatively unknown third party sneak a commit through, well, that's probably something to look at. If we see somebody submit a pull request that instead of the name Jason Gilmore has the name Jason Billmore, well, I mean, there might be a problem there, right? So I really like how Packagecloud is thinking about abstracting this process of ensuring the code that's being assembled, the code that is being deployed is in fact legit. And I think it just goes beyond really digging deeply into any specific solution and thinking more about the human factors, the process factors, and then applying them in such a way that they can better protect their subscribers' IP.
Thanks, Jason. So we're down to the last 5 minutes. Any closing thoughts you want to add, Jason? I think overall, what I would just say is I appreciate everyone's time here today. Hopefully this gave a good, open, big picture perspective of how software is working, where it came from, and where we're going with it, but also highlighted some key questions. If you're a developer, hopefully this raised up some things to either validate how you're doing business and some questions to kind of get into. If you're on the non-tech or business operations side, this is a great list of things you can go back to your developers and engineers and just say, hey, could you sit down with me and explain, how do you guys handle this problem? The odds are they've thought of it, but it's important for you to understand as well what they're doing and what they're thinking about. And if there are gaps, have that open communication. So we know, okay, what are the steps we can take in the future and how do we move forward in a way that's going to better safeguard not just our processes, but our customers who are ultimately using our software. Jason, any final thoughts?
No, other than to thank you, Donnie, and the rest of the Packagecloud team for the opportunity to join the call. And just to close, I'll say I do agree with Donnie. This is hopefully gave you some information that will give you an opportunity to go back and have that larger, more holistic conversation with the team about the big picture with regards to your software processes. It's a lot of fun to talk about features, and it's a lot of fun to talk about your company KPIs, but this really is a big deal. And the first step towards addressing it is having that conversation with the team to kind of air out what everybody's thinking about with regards to how to more effectively manage these dependencies moving forward.
Great. Yeah, I really appreciate that, Jason. For everyone else, please stay in touch going forward. You can always reach us at support@packagecloud.io. You can follow us on LinkedIn and Twitter. We also have a YouTube channel if you're actually using us and want to find out ways to use our software better or do integrations with CI/CD or other things like that. You can go to our YouTube channel and go from there. The last thing I'll say is if you are a developer out there and you are interested in some things we talked about looking at code ancestry and trying to identify ways that we can help manage the dependencies of your software, just ping us at support@packagecloud.io. I'm happy to jump on a call with our CTO with you and kind of talk through. We'd love your feedback, and we'd love to integrate it into what we're working on. So with that, I want to thank everyone for attending today. Appreciate your support of Packagecloud and Treehouse, and reach out to Jason and I anytime if you have questions or we can help you with something. Thanks so much.
Thank you.